We are going to talk about 3.3 today, measures of position. So here is the learning objective. So we talk about the center, variation, and distribution. And we will talk about the outlier later, okay? We have definition, measures of position. So this title for this section is the measures of position, right? Position means we heard that before. When we talk about the median, that's the position. Middle number in the ascending order, right? So we found third and fourth position, right? At the spot. What was it? The position, location. Yeah, location, right? Okay. So measure of position, also called the measure of relative position, measure of location, measure of relative standing. It's measure that indicate where specific observation is positioned in the data set. Yeah, measure of position. So we have a z-score here. All right. So when you hear your professor curve that class, because a lot of people was not good. Yeah, don't reach the average, right? So normally average is 80, generally, right? But then the class curve, right? I don't curve, but class curve, at the time when the class curve, they're using bell shape, and then they're using center dispersion to determine the curve. Yeah. Okay. Now let's talk about the z-score. So also when we use z-score later on, chapter 7, we are talking about more z-score. So z-score is unitless. So regardless of unit, we can compare data set. We are using that too. Okay. We have a definition, z-score. So z-score is from the standard deviation. So z-score measures how many standard deviation on observation is above or below the mean. Because standard deviation is, we have the definition of a standard deviation, average distance each data set from the mean, right? So z-score, so we can think about distance in terms of standard deviation. How about that, right? Let me write down that one. Yeah, it's the same as how many standard deviation on observation is above or below the mean, right? Okay. For sample, we are using the formula. This is z-score x, the data set, minus x bar. What was the x bar? X bar is the mean of a sample and divided by the standard deviation for sample, right? Yeah. And we have a population z-score, then x equal to the data set, and mu will be the population mean, right? And then sigma is the standard deviation for population. Yeah, so actually same formula, right? X minus mean divided by the standard deviation. Yeah, it depends on data set, right? Sample or population. Yeah, okay. Let me write down here. It's a unit list, yeah? So Z-score and unit. This. No unit. Yeah. So even though they have a unit for data set, right? And the X bar and then S, we had a unit, right? But then Z-score itself, we don't have a unit. Okay. And also I want to mention about the Z-score. Z-score is number, right? Since number, we can find the mean, their mean, yeah? So in the Z-score, their mean is 0. And then their standard deviation is the 1, all right? For Z-score, let me write down. Okay, so I wrote down here. All right, let's compute in Z-score here. Okay, so two students made a bet about who would get higher grade on midterm in their respective classes. At least Angelica is taking pre-calculus and scored 87 on her midterm. The professor informed her that grade distribution was bell-shaped with a mean of 69. Yeah, equal to 9. Okay. Let me highlight. And then 87, right? And then let me highlight Jasmine and score 91. Then her class is mean is 76 and standard deviation is 10, yeah? Okay. Who had a better grade relative to their respective class? Who is the best, right? Okay, let's do it. Z-score. Let me write down the formula first. Let's consider, we can just treat sample or population. Either one is okay. Yeah. Would you like to treat the sample? So x minus x bar over s. Okay. In that case, let's talk about the Angelica first. So Angelica score is 87 minus the class mean is 69 over standard deviation is 9, right? Now, can you please calculate? Okay, 2, good. How about Z-score for, what is called the, where we go? Jasmine, right? Jasmine. So her score is 91 minus her class mean 76 over the standard deviation. The deviation is 10. What do you get? Yeah, 1.5. Good. So who is better, right? So Angelica is 2, so higher better, right? Yeah. Okay, so sorry, you did not see that, right? So how do we interpret Z-score in terms of the Angelica's Z-score and then Jasmine's Z-score? Let me write down here. Okay, I wrote down here interpretation. Angelica scored 2. So Z-score is 2. So we are telling Z-score how many standard deviation, right? Yeah. So 2 standard deviation. And then they said above mean. So above means mean equal to 0, right? So we have a positive. 2 is a positive. It's not the negative 2. If we have a negative 2, it's below the mean because mean equal to 0. Make sense? Okay, let me write down later. For her class, and Jasmine's score, so 1.5, we call this as a standard deviation, right? G score is the distance of standard deviation, right? So scored 1.5 standard deviations. Also, this is a positive, so we said above the mean for her class. Make sense? Okay, so I wrote down here, and then we can conclude Angelica is better since Angelica's G score was higher. That is, she scored farther above average in her class than Jasmine did, right? What this mean? This means, look, we have Jasmine G score is 1.5, right? So from the mean, and then this is 1.5, 1.5, right? And then G score is 2. So from the mean, 1, 2, right? Okay. Just by looking score, Jasmine got 4 points up higher than the Angelica, right? So we could think the Jasmine had a better score, right? But then Angelica's, the mean is more lower than Jasmine's mean, right? Yeah, 76, the class mean. Okay, so this score is good for comparing data set. So we found out Angelica is a better score. Make sense? Okay. So we have a picture. Okay, let's talk about G-score more. So we have G-score and then range of G-score, how much, right? So in general, we have a -3 to, this is a -3, and then +3. Yeah. So before pandemic, we're using paper, the G-score chart, G-score table, right? Between -3 to +3. But now we are using software, so we can find more range, right? So until below the -3, above +3 too. But then those numbers are very tiny. Yeah, not usual. Anyway, so let's talk about that. I was talking about above average, right? So this is a positive part. And then z equal to 0 is the mean, right? I talked earlier. Mean is the 0. Okay. So z equal to 0 is the mean. Now, positive part, we said that above average, above mean, right? Negative part, as I mentioned earlier, it's below average. Make sense? Okay. And then let's talk about this one. When Z score is more than 2, unusually high. Yeah. Then more than 3, unusually high, right? Yeah. Then looking at this one, -2, then unusually lower. Yeah. Then more below -3, right? unusually more lower, right? Yeah. Okay. Yeah. So that point, this is what I explained to you earlier, right? So that is the good picture of that. Okay. So we have another Z-score calculation part. So we have average poverty rates in US. So all those states there, right? Verify that data set or bell shape, and then find the mean standard deviation of average poverty rates. And then we want to find and interpret the Z-score of California, Mississippi, and New Hampshire, right? So let's take a look. We have the histogram here, right? So what do you think? Is it bell shape? Yes, it's bell shape, right? Bell shape. And then from the stack crunch, we have mean is 12.03333, and this is a population standard deviation. So let's using the population Z-score formula, okay? All right, so let's do it. Yeah, why we cannot just say that, which one? If we compare with the 3, New Hampshire is lower, huh? Lower. So, Mississippi is higher. Yeah. So, more poor than California and New Hampshire. And then California is in the middle, right? So, yeah. I thought California is rich uh, because everything is expensive here, living cost. Let's calculate the Z-score. All right, so let me write down the formula of Z-score first. Z equal to X minus mu over sigma, right? Okay, so mean is mu and sigma is unadjusted standard deviation in StatCrunch, right? Okay, so California first. Oops. All right. So the rate, how much was the rate? 12.5 mu up there. So 12.03353, right? 1, 2, 3, 4, 5. Yeah. Okay, I'm using all the digits because it's better we keep that. And then if we want to round off at the end, that is much better for accuracy. Okay, and divide by just one time we can carry everything, right? Yeah, not every steps. And then standard deviation is 2.927065. Now, can you please calculate? It's 0.15943, approximately 0.116. Yeah, so I was talking about the before pandemic, we are using Z-score as a paper, like a chart table, right? So in general, we have a Z-score 2 decimal places, and then sometimes a 3 if there is special case, 3 Z-scores, but in general, we have a 2 decimal places. Yeah. Okay, so what this mean? 0.16 standard deviation and then positive, so we can say the above the mean, right? So 0.6 standard deviation above the mean, right? Okay. So slightly more than mean because the mean equal to 0, right? So 0.16, yeah, slightly above, yeah? Okay. All right. So how about Mississippi, 19.8? 19.8 minus 12.03333353 over 2.9270655. Can you please calculate? So 2.6534, which is 2.65, right? Okay, so this score is 2.65, means that 2.65 is standard deviation, right? So 2.65 standard deviation is positive, so above the mean. Yeah, so this is a more, yeah. But then we had earlier, this score is more than 2, less than -2 is unusually high, right? So there will be an unusually high compared with the other, yeah? Compared with other state. Okay, let's do New Hampshire, right? New Hampshire, let me see, 6.4. So New Hampshire, Mississippi. Yeah, just leave. Oh, I forgot. All right, so 6.4 minus 12.03333. One more 3 over 2.9270655. Okay, what do you get? -1.9246, which is -1.92, two decimal places. All right, it's a negative. We can say that -1, so 1.92 standard deviation. Yeah, 1.92. 1.92 standard deviation below the mean, right? Because negative. Yeah. The number itself is a standard deviation, right? Yeah. Above, below, from the mean, we determine, right? So positive, that part, negative, this part, right? Below the mean. Yeah. Okay. Also, this is almost 2, -2. Below -2, also unusually high, right? Yeah. Okay. Then how do we conclude which one has the lower poverty rate than average, right? So it's a negative, New Hampshire, right? Actually, the rate is lower among 3 states, right? California, Mississippi, and New Hampshire, right? But surprise, right? Surprisingly, when you use the Z-score, New Hampshire is the lower one. Yeah, so let me write down. Okay, now we have a new terminology. So if we have a bell shape for location or the position, right? We are using Z-score. What if we have a skewed left, skewed right? Then we are using percentile as a position, location. Okay, so let's talk about definition. So percentile rank of individual observation is the percent of data that are at or below the observation. So when you hear the percentile rank, percentile sounds like a percent, right? So we can think about the percent. It's a percent, yeah, percent of data that are at that point or below the observation. So here is a picture, piece of K. So K% of data is less than or equal to here at the point, right? Okay, that means let's say that P sub 52, how about that, right? P sub 52 from 0 to 100%, right? When you talk about the percent from 0 to 100%, right? So if we say that K equal to 52 percentile, then 52% of data is less than or equal to that piece of 52. Yeah, so let me write down 52% of the example. Yeah, so 52% of the data is less than or equal to piece of 52. Yeah, okay, so we read P sub 52, yeah, subscription, P sub 52, yeah. Okay, so we have an example in the bottom. After taking a standardized exam, you are told that you scored 425, which is at the 85th 85th percentile, right? Interpret meaning of the percentile rank. Okay, so that means so 85% of the other students. Let me write down. What the data is. Or equal to 5% of the other students equals or less than or equal to your score. So 85% of data is less than or equal to a piece of 85. Okay, let me draw. So if we say that piece of this is 0 to 100%, right? Okay, so probably piece of 85, then the data is less than or equal to here at, yeah, below or at. So means 85% of the other students' score were less than or equal to your score, yeah, below or at, right? Okay, in other words, 85% of scores on the standardized test were less than or equal to 420, I'm sorry, 425. Let me write down. Okay, so here is a better picture. So 85% of scores are less than or equal to 425 scores. And then since we have 85 here, and then here is a 15% scores are higher than 425, right? Okay, so let's take a look at example 5. At a healthy baby wellness checkup, you are told that your beautiful baby girl is at the 34th percentile for her weight. You are also told that she is at 57th percentile for her length, not the leg. Okay, the tall, how tall, right? Yeah. Interpret these percentile ranks. Yeah, let's take a look. Your beautiful baby girl is a 34th percentile, right? That means 34% of babies of same age, weight less than or equal to your baby girl, right? Yeah, so 34. So then this is a 34%, then right side will be 66% babies, way more than piece of 34, right? Okay. That means your baby weighs less than the median because we are talking about percentile, right? The median is 5th percentile, right? So let me highlight. Median is the 5th percentile, right? Yeah. Because ascending order. Percentile, we talk about in the ascending order, right? Okay. Okay, how about the length? Length is the 57th percentile. It's a little bit longer, right? Because median is the 50th percentile, right? So 57, yeah. Okay, then other side is a 43% babies, longer than piece of 57, yeah. All right. So percentile always gives the percent of the data that is smaller, less than, or on the left of the individual observation. What this mean? So always below or at, right? That's why this means the first sentence is like that. Yeah. Okay. Then other side, just opposite side. Yeah. So 57, 100 minus 57 is a 43%. Yeah. So that means is that. And then this means is this 100 minus 43%. I'm sorry. 157%. This means 100 times minus 57%, which is 43% example, right? Okay. Okay. Now let's talk about the quartiles. Okay, so when you hear the quartiles, what kind of word? Just click your brain. Yes, it's quarter, right? Quartiles, quarter. And we might think about the percentile too. Tiles, yeah, quartiles. Quarter plus a percentile. How about that? Yeah, percentiles. Yeah, quarter plus percentile. Okay, so and yes, as it is, let's talk about this one. Quartiles of data set are 25th, 50, fifth, 75th, the percentiles. Yeah, okay. Q sub 1, 25th percentile. Fifth sub 50, Q2, Q sub 2, fifth percentile, and Q sub 3, P sub 75, the 75th percentile, right? Okay, so let me explain. So we have a P sub start to 0. How about that? Piece of 100. So 0% to 100%. In the middle, we get 50%, which is piece of 50. Yeah? Okay. In the middle, in the bottom, piece of 25, which is 25%. Yeah? And then upper half, in the middle, piece of 75, which is 75%. Yeah? Okay. So quarter, 1, 2, 3, 4 quarter. Yeah. Okay. Then let's take a look. They say that Q sub 2 is the 5th percentile, which is median, right? So this is a median, right? Median. Let's indicate the M. That is the median, right? So which is also they say the Q sub 2. Let's take a look Q sub 1, 25th percentile. So there will be Q sub 1, right? And then what's about Q sub 3, right? 75th percentile, right? So Q sub 3, yeah? So we answer Q sub 1, Q sub 2, Q sub 3, yeah? We don't answer the 4. Make sense to you? Yeah. So only Q sub 1, Q sub 2, Q sub 3 for quartile. Yeah, here is also a nice picture. Yeah. Okay, so we here is 25%, 25%, another 25%, and 25%. We add up everything up, it's 100%. Yeah. Okay, now how to find the quartile from the data set, right? How did we find the median before, right? We have to make ascending order, same as here. So when we talk about the position, we always make ascending order, right? Yeah, even earlier percentile too. The position, ascending order. All right, then how did we find the median? we determine how many observation there, right? Whether the observation is odd number or even number, right? So odd number, then we make even in order to divide by 2, right? And then if we have an odd number, then we just leave n over 2. Sorry, oh my gosh. Even number. Did I say odd, right? Yeah, I said odd. I probably, yeah. So sorry, one more time. If we had odd number, then we want to make add 1 in order to divide by 2, right? So n plus 1 over 2 position. If, think carefully, if we have a even number, then just leave as it is, n over 2, and n over 2 plus 1 position, right? So for example, n equal to 8, then 8 over 2, which is 4, and we add 1, so fourth and fifth, okay, hold on, fourth and fifth position, right? Yeah, yeah, make sense? Yeah, so basically, once again, let's go back. We know how to find the median. Yeah, all right. Then we are finding another median, bottom half. This is a median. Think median from the bottom half. Yeah. And then look, this one, Q sub 3. There is another median from the top half, right? Median from the top half. So basically, we're finding the median from the older data set, and then we ignore top half, and then we are looking for median for bottom half. Then we ignore the bottom half. We're looking for the median for top half, right? That is quartiles, Q sub 1, Q sub 2, Q sub 3, right? Yeah. So that is the one. Okay. Okay, now let's find the quartiles. All right, so quiz scores. Let's make ascending order first. For quartiles and ascending order. Step ascending order means that from smallest to largest, right? All right. I need your help. 3, 4, 4. Okay, let me write down. 3, 4, 4, 5, 5, 7, 8, 9, 9, 9, 10. Okay, good. All right, now we're gonna find the median for all the data set, right? So before we do that, how many n there? Step 2. How many n? 11. Okay, good. It's an odd number. Then we make even in order to divide by 2, right? So then the median will be the position. So n plus 1 over 2 position. So 11 plus 1 over 2, which is 12 over 2, equal to sixth position, right? Okay, so 6. Let me make one more page. So 1, 2, 3, 4, 5, 6, yeah? 6 position, which is a 7, right? So this is the median, which is Q2, right? 7. All right. Now we ignore from the median to everything, right? So we're looking at only the bottom half. So step 3. Look at bottom half. Ignore the median to upper half. Yeah. Okay, then how many n? So we are looking for another median in the bottom half. So we have 5. All right, so we have 5. Then also odd number. So nice. Better than even, right? So m equal to 5 plus 1 over 2, which is 6 over 2, which is a third position, right? Location. Position means location. So then 1, 2, 3, so 4. So there is a q sub 1, another median, right? So q sub 1 equal to 4. Make sense? Okay, now we are finding another median on top half. So that will be step 3. I'm sorry, 4. Look at bottom, top half. So we're looking at median to here. Yeah. So we're looking at only top. Ignore the median. So ignore the median to bottom half. Okay. So then n equal to how many? 5 again, right? So n equal to 5. Then we don't have to do again, right? So m equal to third position. So there will be ignore the median. So 1, 2, 3. The second line is the median. All right, so there is another median. So it's a q sub 3, right? Q sub 2. So Q3 equal to 9. Yeah, makes sense? All right. Then, so each group, let me see. So let me write down nicely. So Q sub 1, Q sub 1, Q sub 1, I'm recording, right? Q sub 1, 4, Q sub 2, 7, Q sub 3 equal to 9. And then smallest number is 3, right? 3, and largest number 10. So here is a 25%, here is a 25%, here is a 25%, here is a 25%, right? Which is 100% everything. They talk about the quiz score, right? Yeah, but then textbook say that in this case, each group does not have 25% of the data. That is because our data set was very small. Yeah, the data set is very small. Yeah, I see what that means. Yeah, yeah, because looking at this one, yeah. So data set is too tiny, right? From here to here is only two data set. Here to here is only two data set. And here to here, 1, 2, 3, three data set. No, wait, that is the median is here, right? So sorry, I made a mistake. Huh? Good thing I'm checking. Otherwise, so this is a median. This is a Q sub 3. Yeah. So since the small data set, yeah, 25% is not the the case because the data is too small. Make sense to you? Yeah. Okay. Now, then let me erase. I'm gonna show you how to use a Sec3. Okay, 5 number summary. Just a name, like a quartile, right? So same concept with the quartile, but different name, right? So we have minimum and Q sub 1 and median. So quartile using Q sub 2, but in the 5 number summary, we're using median and Q sub 3 and maximum. That is the 5 number summary. That's it. Yeah, and same concept with the quartile. So your homework asks you about the 5 number summary. All right. Okay, can I do one homework then? Okay, so let's talk about the inner quartile range. All right, so we know what was the range, right? So range was the largest data value, the difference between largest and smallest one, right? Now we have inner quartile. So if we have, let me show you in the picture. If we have smallest data set, maximum, and then Q sub 1, Q sub 2, Q sub 3, right? Where's the inner? This will be inner, right? Inside quartile. Make sense? So inner quartile range, then we are using the formula of range, which is largest one in the case is Q sub 3, difference between largest one and smallest one. So Q sub 3 minus Q sub 1 will be inner quartile range. And then we are using first letter IQR. So I from the inner, and then Q from the quartile, and R from the range. Yeah, IQR. Make sense? And then when is good for IQR? IQR is good for when we measure the variation dispersion for skewed data. Skewed data. Yeah. And standard deviation is good for the bell shape, right? Yeah. All right. Okay, so let's do this example. Example 10. contain score, quiz, like earlier, right? Okay, we want to find the inner quartile range. What does it represent? Okay, so let me bring the data set here. Okay, so we had from the earlier previous quiz score, right? So previous quiz score. Okay, now IQR, how do we find Q3 minus Q sub 1, which is 9 minus 4 equal to 5, right? So what this mean? It's inside, we call the middle 50%, right? So 5 is the IQR is the width of containing middle 50% of data, right? So let me write down IQR, which is in the case is 5, is that the middle 50% of data are contained within an interval of that interval of width 5, right? So let me write down. Okay, let's interpret. Before that, let's summarize which statistic is better by the shape. Is it bell shape or skewed right or left? So bell shape, then mean is good for center, standard deviation is good for variation, and measure of position is z-score is good. Yeah. And skewed, median is good because skewed left, then there is more, the lower data set there, right? Skewed right, then there is more, the larger numbers of data set there. So median is really good for measure of center, right? Yeah. Mean is very sensitive, right? So if we have a bigger number, if we have a small number, the mean toward to the smaller or mean toward to the larger, right? So mean is not good for the skewed left, skewed right. Okay, variation. So since skewed left, skewed right, the data set is like there, right? So what is good? Variation is only the middle. It's stable, right? Make sense? That's why we are using IQR, interquartile range, only middle part in the skewed left, skewed right. Yeah. And then measure of position, use a percentile for the skewed left, skewed right. Okay. Now let's take a take a look. So consider histogram for high score grade point averaging. Which measure of center is best for data? Which measure of variation? What would you be? What would you use to describe relative position in the data? Can you think? So this histogram looks like what? Skewed left, right? So skewed left, then we are using this one, right? Skewed left. Let me just copy. Yeah, since skewed left, we are using that, right? Okay. How about this? Yeah, so this one looks like, what do you think? Better shape, yeah. Okay, then we are using mean for center, standard deviation for variation, and z-score, right? So this bell shape. Mean standard deviation. Let me denote like that. And z-score for position, right? I'll go for center, measuring, just using the center, variation, and position. Yeah. Okay, how about this? Okay, so last question. What do you think about this one? So this shape, distribution is skewed right. Then we using measure for center median, right? So median, let me write down. Since skewed right, median and IQR and this not this G score percentile, right? So percentile. Go for measuring, yeah. Center variation and the position, right? Okay. We done for this section. Thank you for watching. I will see you in next section. Thank you. Bye.